this is the last problem we're going to learn how to do today. Really quickly, it is example 8.15, 8.15, 0.15. And what it's having you do is calculate the partial pressure of a gas when you only know the total pressure. So in example 8.15, we are given the total pressure as 192 kPa. kPa, it should be capital. There you go. And so about roughly 1.9, 1.8 atmospheres, somewhere in that region. And we're going to calculate how many, or the partial pressures of each of these gases. So we know we have a mixture of gas between 2.83 moles of oxygen and 8.41 moles of nitrogen, or nitrous oxide. All right, so different molarities here, and all mixed together in one gas with a pressure of 192 kilopascals. Now, how do we figure out how much oxygen is contributing to the pressure and how much nitrous oxide is contributing to the pressure? Well, we have to figure out proportionally how much these stack up against each other. So the way to do that is to take the number of moles and divide it by the number of total moles in the sample. That's called the mole fraction. And again, for those of you who didn't catch that, you're just taking the number of moles of your sample, so 2.82, and dividing it by the total. So 8.41 plus 2.82. All right. So that is going to give you a decimal place, no units, because everything's in moles, and that's going to cancel each other out because this is in moles and then this is in moles right here. So because everything is in moles, all the units cancel and we just end up with a number. Right? For this first one, that's going to be 0.252. All right. Now, all we have to do is multiply this mole fraction by the total pressure, because the number of moles of oxygen is basically 25.2% of the gas. And so it's going to be contributing 25.2% of the total pressure. So if we multiply that, 0.252 times 192 kPa, we get the amount of pressure, or the partial pressure, of the oxygen gas. And that comes out to 48.4 kilopascals. Okay. So then all we have to do is the same thing for nitrous oxide. I'm going to get a different color since my marker's drying out. And that is going to be 8.41 moles divided by the sum of both. So 8.41 moles plus 2.82 moles. All right, all the moles cancel. And we are given a fraction of 0.748, which should be, this number, or 1 minus this number, since this is 25.2%. It makes sense that we have 74.8% of the pressure being contributed by nitrous oxide. But we take that, we multiply it by the total pressure, 1.92 kPa, and we get a partial pressure of 143.6 kilopascals. Now, if we want to check our answer, we should add these two together and get the total number of pressure. So on your calculators at home, type in 143.6, add 48.4, and you get 192 kilopascals. So we know we got our answer correct, and we can move on to the next problem. So that's it for today in terms of partial pressure. For your homework, you're going to be doing problem 59, as well as a problem I wrote, just because it follows the example a little bit more closely, but that one's going to be posted in the Google Classroom assignment